So if you've heard of Podman before, it's likely your exposure to Podman has been from the CLI tool. So our Docker equivalent container engine that we ship with Red Hat Enterprise Linux. And you can do things from the command line with Podman that you can with Docker as well. And it's likely you've probably come across some exposure here. What I'd like to show you today is our GUI equivalent of the Podman CLI tool that we call Podman Desktop. So this gives you the same ability to run images, run containers, create images, move them around, do local development in containers on your laptop, and then ultimately have a few options which we call extensions and plugins to push that work to a Kubernetes environment. So this GUI tool ties into the local CLI tool, or rather the Podman utility that's running. So what we're viewing here is the Podman desktop dashboard, which gives us an overview of the different extensions that we have installed. We see we've got Podman version 4.9 installed on the local laptop here. And there's a variety of extensions that we're able to add to Podman desktop for use. We can create things like a kind cluster or Minikube or an OpenShift local environment for pushing of our local development work into a Kubernetes environment. We've got container images here as well in Podman desktop. So we'll see two images here, and you'll note that these two images are the same ones that we saw from the command line tool. So what you see from the CLI perspective is also what you'll see from the Podman desktop GUI perspective. From here, we can do a building of these images into formal containers. So we can do that here. We can run containers, we can build them, we can import them from images. We've also got a section here on the left for pods, so we can group like-minded containers or what we want from a container perspective into a pod. So we can group, a front end and a back end, for example, which we'll do later in this demo, into a pod. So we get a Kubernetes-like primitive here. And we've also got some exposure to some volumes which we'd mount in our containers for a persistent volume store. Moving on from container volumes, we'll go to the bottom left here into settings. And here we'll see some resources that we can set up. The big one that we're going to use here today is in the third one down, called the Developer Sandbox. Basically, what this does is it will allow us to link Podman Desktop here to a OpenShift environment and allow us to push container images or pods into the formal OpenShift environment right from within our Podman Desktop GUI here. So this makes for easy movement of what we develop locally in containers into a formal Kubernetes environment. We've also got a section here for registries. So if we needed to set up authentication into Docker Hub, GitHub, Google Container Registry, Red Hat Quay, we can do that here as well. Additionally, you can set some proxy related information, add some authentication providers, list some of the Kubernetes contexts that are known to Podman Desktop, and manage some extensions and other preferences here as well in the settings. Hopefully that gives you a highlight overview of what we have available in the GUI here. We've got a section for images that we can import, build, and manage. We've got a section for containers where we can build, start, stop, run, manipulate containers, as well as group them into pods. And we've got a section for persistent volumes where we can manage what we would ultimately present to containers. So a lot of the basic foundational container development, container management use cases we've got here in Podman Desktop. Now let's jump over to Microsoft VS Code. I'd like to give you a bit of an overview of what we're going to demo today. And it's not critical to understand the application that we have here, but I'll include the GitHub repository links here in case you want to go replicate this demo yourself or dive a little bit deeper into the application that we're going to use. But what we're going to highlight here is more so of the container management and workflow rather than the application development itself. And so what we've got here today is a basic two-tier application. We're going to use a Python application built with Flask to create a hit counter on a web page as our front end, and we're going to use a Redis database as our back end that's going to store the hits that are counted. And what we've got here is a mix of the Python application that's been created here on the right hand side. We've got the entry point that's going to be run and packaged with our container, and we've got on the left here the Docker file or the container file that we would use to build this container. And again, it's not critical to understand any of these components themselves. Rather, what we're going to be focusing on is the local workflow of how you would build a container image or import one, i.e. we're going to show you how to import this Docker file locally in Podman desktop and build a container image that contains this Python app. As well, we're going to connect it to another container image of a Redis backend, and we'll show you all how that works. And then what we'll also show or highlight here is the workflow for building these containers. So taking an application that you've built, packaging it locally on your laptop for testing, running, making sure everything works, and then ultimately giving you an avenue to promote that work, if you will, into an environment like Kubernetes, where we would ultimately, run more unit tests, integration tests, smoke testing, or potentially push it to a production environment or have some more CI or CD processes applied to it here. But what we mostly want to highlight is what we're able to do from a local development perspective in containers on our laptop, and then the options to formally push that work right to a Kubernetes environment. So let's jump right in. Let's take this Docker file or container file that we have here and let's build it. So I'm going to move over to Podman desktop here, and I'm in the images section, and on the top right hand side here I'm going to click build. I'm going to provide it our Docker file example, and I'm going to give it an image name of Python app, and I'll click build. And you'll notice here it's going to go through and install our dependencies, build the container image according to the container file spec that we created. And you'll notice whether you're using Podman or Docker or any other OCI compliant container engine, the output here is going to be the same. Of course, Podman desktop and Podman are OCI compliant. And so you'll see at the end here we've got a finished container image tagged Python app. So then after building that image, you'll notice here we've got a new image called Python app in our local Podman registry here. Now, something else we can do within Podman desktop is push this container image that we've made to a centralized registry where we might actually deploy from, as opposed to using the local developer workflow on our laptop. So what we can do is go into settings and registries, and you'll see here I've got a registry configured for Red Hat Quay, but of course you could use any of the other registries here, Docker Hub, GitHub, etc., to push this image to. And so what I'm going to do here is rename this image. Instead of doing a CLI command, I'm just going to do this from within Podman desktop itself. I'll rename this image and use my quay.io account. And so now what we'll also be able to do is push this image up to a registry. And it's going to use those credentials that were defined in Podman desktop in the settings section to authenticate and upload this image to that repository or that registry. So let's go ahead and start assembling this two-tier application. I'm going to start by running the Redis image here into a container. So I'll click on run. I'll give it a name of Redis. We don't need to do anything fancy here as far as volumes or environment variables. Again, this is just a demonstration. So I'll go ahead and start the container. Now this puts us into the container section of Podman desktop, and you can see from the tabs here at the top, we've got a variety of the common commands that you'd probably do with Docker or Podman, i.e., Podman logs, Docker inspect, etc., etc. So we've got that summarized here at the top in these tabs. We can see the state of the container itself. We can see the logs of the container. We can get an inspection of the container variables itself and what we would use from a container runtime perspective to interact with it. What I also really like is Podman's ability to do Kubernetes YAML formatting. So what we can do here is we can get a YAML compliant and an OCI compliant Kubernetes YAML file that we can use to re-represent this in a Kubernetes environment. And so, granted, this is a very basic example here, but this becomes a lot more valuable once we start getting into mounted volumes, more advanced networking, and those type of pieces. This becomes a really handy piece of the Podman desktop. And of course, we have a terminal available here as well. This is essentially SSHing into the running container and interacting with it. So let's show you an example of interacting with the Redis container. I'm in the terminal session here. Essentially, again, we've logged in via SSH to this running container. I can do something like interact with the Redis CLI. We can say we can set a variable and then do a get of the variable, right? And so this simulates, again, SSHing into the running container and interacting with it. So now that we've got the running Redis container and essentially our back end set up for this two-tier application, let's go and start our front end of this application using this container image that we built. And again, we can do the same process. Click on the container image and go run, and we'll get a variety of configurables that we can pass to this container. But before we do that, we're going to need to be able to tell this container, the front end container, how to find the back end container. So before we create the Python app container itself, let's go back to the Redis container and go into the inspect section. And one of the things that we're going to need here is the IP address. So I will search for IP address here, and we're going to need to input this into the networking portion of the Python app container that we're about to create. And so again, you can see how helpful the inspect section here of running containers are. So let's go back to images and let's run the Python app container. I will give it a name again of Python app, and I will go into networking and I will call the host name Redis, and I will specify the IP address, and we'll click start container. And so again, we'll get another running container here. You'll see the similar tab view that we have for this container like we did the Redis one. We've got a summary of the running container and its ID. We've got logs, we've got inspect, kube, and again, an SSH session. So now that we've got that second container created and connected into the backend Redis container, let's show you the app in action. So I'll go into the Python app container and we'll go into the log section, and we will also open up the URL. And you can see this is what the application shows us. It's a hit counter, and the number of times the website has been viewed is what is stored in the Redis backend. Put in another way that's a little easier to view. Let's do a split screen here so I can show this to you live. And you can see the requests go into the Python Flask container, and they get reflected in the logs here. So again, very basic example of a two-tier containerized application. but hopefully that gives you a pretty good overview of what we're able to do from a Podman desktop perspective as far as some of the more common developer workflows that we would do during local development on our laptop, right? We built a container image from a container file or a Docker file that encompasses our application. We were able to populate images in our local container registry on our laptop, such as Redis and Universal Base Image that we built the Python app from. We're able to build that container image with our app included in there. We were able to start a Redis backend container and ultimately the front end container and have this work side by side in a deployment. So hopefully you found that interesting. But let's do something even more interesting. So what we've done up to date is mimic a lot of the common development workflow that we would do locally on our laptop. Now let's focus on the side of the demo that's translating and taking that work locally and ultimately pushing it into a Kubernetes environment that might more closely mimic production and where we would ultimately run this application. So from the container view in Podman Desktop, I'll select both containers and I'll click on this button in the middle called Create Pod. And as you can probably guess, what this is going to do is it's going to copy these two running containers into a pod, as well as all the resources for those containers, like selected ports, volumes, etc. And it's going to group them all together into a Kubernetes-based pod. And so what this will allow us to do is move this pod around and ultimately, move this into a Kubernetes or OpenShift environment. And so we see here I created this pod called Rug Pod, and we can go into the container section and see there is a couple of containers here copied into it. And we can go into this pod and see each of the containers running here, Python app and Redis. We can get a summary of each of these containers here as well. We can get the same inspection content and ultimately another combined Kubernetes YAML formatted option here as well. So a couple of things that creating this pod allows us to do is we can generate a kube manifest from Podman Desktop here itself. So if we wanted to import this into another Podman Desktop instance, or if you wanted to send this to a developer colleague, you can generate a kube manifest to send over to them. Additionally, we can import one or play Kubernetes YAML if we wanted to import another pod and its resources contained within. We could do that here as well from Podman Desktop. So pretty interesting option here as far as the portability of what we're doing locally for development and packaging of containers on our top, and ultimately giving us a facility to transfer that to other environments. So let's show you how we would send this pod or deploy this pod into a Kubernetes environment. If you remember at the start of the demo, we went into Podman Desktop and set up a developer sandbox. This is our OpenShift cluster that we're going to deploy this pod into. So I'll also show you the OpenShift environment here, and I'm in the developer view at the moment, and you can see that there's currently no applications or pods running here, but let's change that. So I'll select the rug pod here, and I will go deploy to Kubernetes. And so again, we'll see a familiar Kubernetes YAML manifest. We'll see the Kubernetes context in which we're going to deploy, i.e. that is our OpenShift environment, and I'll click deploy. Now we'll get some feedback here, some verbosity at the bottom as this sends this deployment over to OpenShift. What it's going to do is provide the container images, or the references to them rather, over into the OpenShift environment, as well as the routes and the services here. And again, all that's captured in the Kubernetes manifest. And if I move back over to OpenShift here, we'll see that this rug pod has been deployed. And so now that this pod and application have been deployed here. Let's check it out. And again, you can see that our Python app has been moved to OpenShift. We're accessing it right out of the OpenShift environment, and that's it. That's largely the process for taking that local development environment from our laptop and pushing it into Kubernetes environment. And as we've got the pod here, again, you can go through a lot of the different tabs and areas that we saw in Podman desktop, i.e. we've got the logs here, some environment details, the YAML and the manifest, the Prometheus metrics, details about the pod, and again the terminal where we can log into it. So pretty interesting from a local development workflow perspective.